Welcome back, everybody, to day 3 of the Deep Learning Intensive with our concentration on transformer models. So yesterday, for the very first time, you got to actually do some coding with transformers. And you got some really good experience with working with pipelines, which is the simplest way to work with the transformer models, especially when you're doing, you're working with pre-trained models and you're not doing any additional training on those models. So you realize that there's a wide variety of models that you can use to solve different types of tasks. I'd like to sort of highlight the fact that those pipeline tasks only cover, a slice. It's a very important slice, but a slice of what transformer models are capable of. It turns out that there are some very different types of models for which there are not pipelines yet, because this is brand new, cutting edge. It seems like each week there's a new pipeline that is created. So for example, there's not yet a pipeline for vision transformers. So many of you are interested in images. There are vision transformers which work with images that do that same type of learning, where it learns representations of greater and greater sophistication. And this seems to be capturing signal and meaning and concepts. You've seen this in the text. It appears that a very similar thing happens in images. There's also the wave to vec, which does the same type of learning, but over sound files. So you have models, for example, which learn language by listening to the spoken language. And interesting finding there is that by training on many different languages, you can learn on an unknown language in a remarkably short period of time, because those conceptual representations of, the idea of a verb, the idea of a noun, however that's presented in a particular language, the model learns those things, and so then is able to translate very well with languages it's never heard before after just a few additional hours of training. So small sample. I'll actually be talking more tomorrow, the very beginning of tomorrow, about these other types of applications of transformers. So again, yesterday you got a chance to explore those models. You got some good practice using Collab and using the repos with Collab. You also got some good practice on how to get to data. It turns out there are many different ways of getting to data. Using Google Drive is a simple one. There are some very nice routines that are already written, utilities that are written that get to Dropbox and a number of others, not Box yet, but I imagine that it's on its way, but not here yet. The other interesting thing, though, is that the discussion is actually to fold that into the basic routines. And so they won't be separate utilities. You'll actually be able to just reference and load data directly in from those sources. So everything about the growth and the transformation of all of these models in Hugging Face is to make it simpler and simpler for you to be able to load data and to do your work. So you're getting on this train at just the right time. Today, we're going to be taking that extra step of what you need to do in case your model isn't quite up to the task yet. And it could be not up to the task because it's not performing as well. It could be not quite up to the task because let's say that you want to do named entity recognition, but you want to actually name a kind of entity that isn't, an organization, place, person. I forgot what the fourth thing is that the base NER does. But in those types of cases, if you need to expand the capability of your model, you're going to have to know how to do additional training. So we're going to be talking about a way to do that locally today. Know that tomorrow we'll also, or at the end of today, we'll also talk about Hugging Face's offering of doing training when you have a very large corpus and for which you may not have the compute. I announced yesterday that we actually will soon have significant compute on the Vanderbilt campus with our DGX A100s. So even if you have a pretty heavy training, we could possibly do that on-prem as well. Dr. Bell, was there anything else you wanted me to mention before I turned it over to you?
I think you covered it all. Thanks for that overview.
All right.
All right. So as Jesse said, today we are jumping into fine-tuning our models in the case that maybe the default model or the model that we selected isn't quite what we're looking for in terms of performance. And again, so we're all here to assist in anything you need. Please feel free to slow us down or ask for assistance, send messages through chat, or send us other types of messages. Okay, so as you guys have discovered, and Jesse also talked about, so the Hugging Face API really is just evolving very quickly. And so it's like every time we look at the API, there's something new there. So again, this intensive is really focused on learning skills related to a bit of the theory about deep learning, but really being able to use the resources that are available to you to be able to move forward with the work that you're interested in. So we are going to continue with that today. Okay. So yesterday, someone asked a very interesting question. And they asked about where we could find more information about models. And this is just a really great question. So I can show you two places, but we're going to start with one that is super interesting. So let me send that to the chat. And then I will share my screen as well. There you go. So let's just hop on over there. I'll share my screen. Okay, this should be big enough. All right, let's share. And here we go. Interesting. So this is pretty exciting. So we talked a little bit about that there are models, one, and we talked also about that there are different types of models available. And so this page in particular is really great about enumerating the models that are available, as well as some of the tasks that they've been fine-tuned on in particular. So for example, if we're just looking at to find any kind of model, we might just look here. And if we're interested in finding a specific model type, we might also use the search menu to be able to access that. So I will say sometimes it's really great to just directly Google this and like try to use keywords that are around your model that you're interested in with Hugging Face. So with that keyword, but often you can kind of get to it kind of typing in your general keywords. So let's say, for example, that I'm interested in legal text. So maybe I just start here and I type in legal. Let's see. Oh, it looks like there are some models here that have been fine-tuned on some legal text. So that's what it's looking like to me already. So that's pretty exciting. So there are also some that have been specifically fine-tuned on specific tasks as well that are available through the inference API. So this is a lot to look at here. Maybe I want to pare that down by some of the tasks that are available specifically. So maybe I want to just see the ones that are able through the API to do question answering. Interesting. It looks like there's one there. I wonder what this is about. Let's click it. So this is not the most helpful example in terms of understanding what's going on with the model. This thing right here is the model card, and it often tells you a lot about what's going on with the model. So we'll come back to that particular thing, but something that's really just like super exciting to me, and I think it's exciting to everyone, to be honest, is if you want to try this out right now, you can actually use the hosted inference API, enter some context. So if you have some random legal text that you just have sitting by you for whatever reason, maybe you're having some legal struggles, you can just go ahead and paste this right, if you want to, right in here, and then ask a question given that context. And so this one has specifically been trained on legal information.
Hey, Miriam.
So we're actually just going to go back right quick.
I'm at home.
And maybe, so I'm going to clear this so it stops telling me about question answering. And I'm also going to clear this. And let's just look at a general model. So let's just look at this one. So this is BERT-based uncased. So that should look familiar. We might have said, oh, did we see that yesterday? So So here is the model card that tells us all that great information that I think everyone was looking for. So something that's really exciting here, again, we have the inference API here, which is also very nice if we want to try it out directly. But this tells us a lot of things, and I really love that this tends to have references to the actual papers where it was implemented and how it was tested. So often there's a very, high level description of what the model is, often what it's been trained on, and often the tasks that it's able to do. And there's often ways that they present on how to use them. So these could be really great if the creator creates these model cards, and you can also request that the creator creates the model card as well. So you can request that as well. So these, I almost didn't scroll far enough. So this is a really great area about the training data. I know some people were asking about that. Well, what exactly was it trained on? So often that's in the paper, but also this information does tend to appear in the model card as well. So here, book corpus, 11,000 unpublished books in English Wikipedia. So that is some good information. And boy, is that a lot of text. All right, so if you like, you can keep reading on to those things. And you can learn a little bit more about those models. So now let's just take a moment. Well, let's do another example right quick. So sometimes, as I was saying, it can be a little interesting to try to nail down through this particular interface the model that you're looking for. You have to kind of know some of the keywords. So maybe I'm trying to do like a medical classification or some kind of medical text. So I might type in medical. Oh, so it looks like there's some medical things here that might be able to help me out. Maybe I want it to be specifically on surgical notes. Well, I didn't spell that right. Surgical, maybe not a good keyword. Surgery, maybe not good. So if you were to perform a Google search to try to understand what models are available, you would know that there's a class of, or you might find that there's a class of models that tend to start with biopolitical. So this kind of thing. And so that might not be something that you would have just intuitively guessed, but this is something that can be found kind of through Google. So we have like PubMed, OnCase, and all these different techniques we can use. And again, we can just see if there's anything that's already been kind of trained specifically that we might be able to access through this inference API. So it looks like there's a lot here that we might be able to use. Maybe a zero shot. Oh, no zero shot. That's okay. So now we're just going to take a few minutes. I know that you all have your own applications that you're interested in applying. And do keep in mind, like you don't, like these are models that are available and they might already have the ability to perform the tasks that you're interested in. And if that's so, you don't really have to fine tune them if they serve your purpose. So just take a look at what's available here and Google and use keywords in this model's website search bar to see if you can find any that might be suitable for your purpose. So we're just going to take maybe 3-4 minutes to give that a try. It also may be fun to try out some of the different tasks available through the API as well.
And for this, we're working quietly at our desks rather than going to the breakout rooms.
Sorry, I really did not say that at all, did I? I just started looking at this and I was like, oh, buttons to click. Yes, so we're going to be working quietly at our desks, as you said, for about 3 or 4 minutes. And let me go ahead and just start a timer so I don't get too distracted by what we have available here. And I'll stop sharing my screen. There you go. Have your full model there. Full screen. All right, did anyone find some models that they'd like to share? Anything interesting that you found for your application? And you can feel free to either unmute and just kind of talk, or you can drop it in the chat.
Jesse, I think you had one in mind.
I did. I was letting other people go, but because I mean, I didn't find it just now. I already knew about it. It's called Finbert. So if you, I don't know if you want to search for it, if you want me to share my screen and show you, I was just looking at it.
Oh, well, I can give it a try. You can just tell me where exactly I should click. All right, so I see these Finberts.
Yeah, it's the Process AI one, first one.
What? Oh, fun. And what is this one doing? This looks really great. So it looks like it's, ooh, analyzing sentiments of financial text. That's quite interesting. How do you think that, like, are you planning to like apply that?
Well, so there's already been a lot of work done on analyzing sentiment around earnings calls and in firm filings, like their annual reports. So one of the things that we were going to look at is equity analyst reports. These are like third-party research analysts that are making recommendations about buy, sell, hold on different firms. And they give a report with kind of a headline recommendation of buy, sell, hold. And there's a lot of research about those recommendations and kind of averaging them. But I don't know of anything that's been done looking at the text of those reports to see how that may or may not align with the headline recommendations. So that's kind of what we're looking at.
Interesting. I like that. That's really cool. Oh, I'm clicking buttons again. Oh, but that one was actually pretty quick. So we can see that it does. Nice sentiment classification. And I guess this is a little bit, I mean, it's fine too. So it's specific really to relating to financial data. That's pretty cool. I see someone also put in ArcheoBert JE. That one sounds pretty interesting as well. I'm going to try to look that one up.
Yeah, I mean, it's just the two archaeological, they're very specific to Dutch archaeological reports to search within the corpus, but it would be very handy if it was a little broader.
No, let's see. I'm not finding that one.
And I might also point out that a lot of these fine-tuned models are not done by the big corporations. These are models that they take BERT. So one of the contributions that we can make back to the scientific community is when we do this fine-tuning, if this is something that has general use, absolutely we can give this back and actually then give those models and put them up on a Hugging Face ourselves. So for example, if you have a particular corpus, Mark, I'm thinking, especially your work and others as well. Once we do this fine training, you might want to consider actually giving this back as well as a special fine-tuned models on Hugging Face.
I love that idea. And we're actually going to talk a little bit later today about how we can actually do that. All right, fantastic. So let's say, okay, so maybe, oh, I went to the wrong thing. Click the wrong thing. Anyways, just by the way, so you know, as you're navigating this website in the API, so this is like the Hugging Face website. If you ever want to get back to that particular page, it's right here under models. There's other ways. So going to this resources tab. So later there's going to be a breakout room where it might be interesting to examine some of these specific links. So perhaps maybe metrics or data sets. Those could come in handy later. But okay, well, got a little distracted there. It's okay. But maybe we want to fine tune one of these specific ones. Again, maybe it's not exactly what we're looking for. Maybe there's not a fine tuned model in our area that we're looking for. And so then we say to ourselves, all right, well, how am I supposed to go about fine tuning this model? Okay. So that might be the question that we ask ourselves. So now let's talk about how we can resolve that question. How can we use the API in order to address this? So I'm going to jump over here to this resources tab just to show you a little bit about the navigation here. We're going to go on down to transformers because transformers is, I mean, that's the API that we're using to access all of the pipelines and the models. So we're just going to hop on down to that. This should look very familiar. We saw this website a lot yesterday, right? So we saw this sidebar. We saw that there's some nice getting started parts. There's some summaries about just generally using transformers. We saw that there's some advanced guides. So something that we talked about in the Python class was about classes in general. So we started investigating this pipelines class yesterday. And there are some other ones here that again may come up in a later breakout room. Okay. But so now we're on this API and we're like, all right, well, how are we supposed to fine tune this model? Well, we take a look at the API and we just look, oh my goodness. I wonder if this can help. It says fine tune a pre-trained model. Okay, let's click on that one. Oh, look, it gives us some information and it tells us some things. It looks like we have some really good code here that may help us. Interesting and very exciting. We know what this badge is. This gives us the ability to open this page in Collab and experiment on our own. Interesting. So normally that's what we would do, but I think this link right here is just a little bit special right now, and it might be linked to the wrong notebook. And so we have just created another notebook in the repository so that you'll be able to run these things yourselves. So let's see, let me just send out that link. So this is going to be the link to our intensive workshop repo. And so this should look, again, very familiar. There are a few notebooks added here, so these later ones that we'll be using today. But this 3 fine-tuning notebook is the one that we want to be in. So again, if we click here, it's just going to open it up in the repo and it's not going to be interactive. We do want to open this using Collab. So let's go ahead and click that. Open in Collab. And then we are going to open this 3 fine-tuning overview notebook. There we go. And we don't need to mount any drives today. We are really just going through, okay, not today, in this particular notebook. We don't need to mount any here. We're just going through exactly what they have here. So actually what I'm going to do is I'm just going to try to attempt what we did yesterday just a bit. So we're just going to stick that over there, stick this over here, and work on these 2 things together. All right, so what we're going to do right now is we're going to, so you guys are going to go into breakout rooms for about 8 minutes. 8 minutes, I think we said 8 to 10 minutes. And you are going to read over this fine-tuning a pre-trained model. And again, this code is going to match exactly, pretty much exactly match this code over here. And what you're going to try to do is using some of the information that's presented in what would be the markdown, you're going to try to label these code chunks according to what you think they're doing. So for example, they don't have this one here, but we know that we need this because we're on Collab. We might instead decide to label this one to be, oh, sorry. Well, let's get out that. If we can we do it? Well, okay, well, let's try it. So we might label this download relevant packages or something. So that's what we might name that one. This one is also like not actually there. So like I said, like a little bit, we did add some extra things here. But from here on down, it should be pretty much identical. So for example, another example here, and basically what I'm doing right now is I'm just double clicking this. It actually shows the markdown here. I don't usually use Collab. I usually sit on Acre on my own computer. But I love that it shows just the rendering right there. That's really nice. But here is where you'll add, where the question marks are, your heading. So here, this might just be import relevant packages. Relevant. And then I'm just clicking Shift Enter to render that one. Okay, so again, what you're doing is you're just reading through this and trying to label these code chunks here with what is going on. So like a brief heading of what's going on in those code chunks. And we're going to go into breakout rooms, but it'll be best if someone shares their screen and maybe everyone can kind of collaborate on what they feel that the heading should be or what's going on in that code chunk.
And shall we do 4 to 5 people in a room? Does that sound good?
Sure, that sounds great.
Great. And how long would you like to have this breakout room for?
I think we're going to have this for about 8 minutes.
8 minutes? Okay, great. And folks, you'll be able to return to the main room at any time. I'm going to automatically move everyone in, and we'll see you all in about 8 minutes. Welcome back, everybody. Oh, welcome back. Here we come. Welcome back, everyone.
All right, well, I'm going to share my screen again. Let's see. And let's see what you came up with. So, real quick, I should have not shared my screen before this, but was anyone able to get through, let's see, all 10 steps? You can put a thumbs up in the participants or using reactions. Oh. Okay, that's looking good. It's looking good. Where most people, so put a thumbs up if you were able to get through, let's see, number 7.
Ooh. Looks like about 8 people.
All right, that's looking good. All right, and then if you were able to get through number, let's see, 5.
About 4.
All right, that's looking, nice job, you guys. Nice job. I know sometimes reading this, it looks like chicken, it looks crazy sometimes. But let's work together and try to parse out what these things mean. It'd be really nice if I could. Nope. Nope. Okay. That's not what's going to happen. Okay, so number 3, let me open the chat as well. Sorry, so many windows, so many windows. Okay, so what did people kind of think about number 3? Here we have a low data set, and it's this IMDb thing, IMDb data set here. And we get back the raw data sets. What were we doing there? And again, feel free to drop it in the chat, or you can just unmute and tell us. I see. Okay, read in the data. All right, that's sounding good. Yep. So read data. Yep, reading. Oh, okay, I like that too. Load data. Okay, I like that. Okay, it's looking good. Oh, and I meant to say, I may not run all these cells, but you can run all these cells if you like to. Some of them are, they can be a little bit lengthy, but I think our objective here is kind of to understand what's going on in the code. But do keep in mind that after this workshop, if we don't end up running all of these, that you should go through these so you can look at the data types and look at the classes and examine them so you can extend what we've talked about today in class or during this workshop. Sorry. Okay, so now, okay, so we've loaded the data. Okay, so that's looking good. Did I already run this? Oh, no. Just gonna write it again. All right. So this is what I'm talking. So I just kind of put this one in here. This is a type. And we're just going to try to understand what this type of this data is. That might help to inform us about what kind of data that we can use in the future or how we might think about setting it up or what part of the API we might need to go to in order to look at how we need to set things up. So again, might take a second, but we're just going to go move right on. Okay, so we loaded the data here. And then we're doing something here. So what was this 4 heading? what does that look like? It's auto tokenizer. Okay, so it looks like we're using some tokenizer. And then from pre-trained, BERT case, base case. And then here we just print out the tokenizer name. So what will we call this section? What do you think? Interesting. So this number 4, okay. Okay, I like that. So loading tokenizer for that specific model. Yes, let's call it that. I like that. Load tokenizer. And here this does get into a little bit of the minutia about like the difference between kind of like loading something versus doing something with the thing that you've loaded. So this one is just loading the tokenizer. And here we just have this additional line that we talked about yesterday where we could print out its name or path. Okay, so here, so this was just kind of like a fake little thing that they wrote here so they could kind of tell you what the objectives were. But then we get to this tokenize function. Interesting. So let's look at that one. It looks like the objective is that we use this raw data sets thing and we call map on it. Map is familiar to Python and it's also familiar to R, and it's just like a really special for loop. But this is a special kind of data set, and so they implement map just a little bit differently under the covers just because fast. So it looks like we're using this function on this data. And what is this function doing? It's using that tokenizer that we just loaded, and we are passing into the tokenizer our actual text. We're doing a little bit of padding to the max length. We'll come back to this because it's very interesting. And then we're also going to be doing some truncation. And I think they talk a little bit, yes, they talk a little bit about that. Okay, so what might we call this step? Can you guys see this? Make that a little bit bigger. Can't see it. Okay. So what might we call this step? I think some people might have said it for the previous step, and those statements were looking really good. Interesting. Okay. Oh, I like that. So pre-processing data. I like that. Let's call it that. Pre-processing the data. I like that someone is saying user-defined function. So we are pre-processing the data using this user-defined function. So I like that. All right, so then we get into this little chunk here. Looks like we are using this tokenized data set that we just got back. We are seeing that it has these different splits. And so later on, I would suggest you come back and see what this data type is. But we see that we have some different types of splits here. Looks like we shuffle it and then we select some of it. And we make a small training data set, a small evaluation data set, and then these are just the tokenized data sets for the full data sets. So shuffle, and then we get some small subset. What might we call that step? Oh, someone already said, I like that. So we're going to call this one split data. I'm liking that. Okay. Then we have this one where, okay, so here we see that we're going into the fine tuning with the trainer API. Interesting, trainer. Looks like this is a link to something. Wonder what would happen if we click that. We'll find out. So here it says, okay, we're importing this auto model for sequence classification because we're trying to do sequence classification here. And it looks like we are getting this model. And we're saying we're going to try to do classification on 2 labels. And we're returning a model, and then we just inserted this again just so we can print that out. And keep in mind, I think yesterday we talked about using, I think it was like pipeline.model, which printed the whole model. But we can also do pipeline.model.name or path. And then this will give you information similar to what we saw with the tokenizer. Anyways, so what do we think that we would call this step? Thoughts? I like that. All right, define model. create model. I like that. I'm liking those. Let's use that one. Create model for task. Okay. All right. So we got that model. Now it says, it's saying a lot of things here. Oh, it's saying, interesting. Oh man. See, this is one I really would have liked to. Let me see. Let's see if I can run these real quick. Woo, this might take a little time here. All right, so let's run through this one. So this is a very interesting statement. It's saying that, so you'll see this if you decide to run this, but if you don't run it, you'll also see this in later notebooks so we didn't run it. And it says something about the pre-trained weights not being used, in some ways being a randomly initialized. So this is saying we are just taking like that layer, and so there's like this layer at the end which actually does the task, and we're just putting some numbers in there because we don't actually know what that is right now because we're using the base. And so that is what we're going to fine tune on this task, or that's a part of what we're going to fine tune on this task. And we're going to be able to transfer the model, the knowledge of this pre-trained model to also this task. So this is what's going on with fine tuning here. And this is what it means to be doing transfer learning. Okay. So these are taking their good time. That's okay. We're making it. So let's see. Now we're on training arguments. So it looks like we're going to pass in something. We're passing in something here. So it looks like we are. So here you see that error that they were talking about. It's saying some of these weights, those ones specifically, don't really know what's going on those. So it gives you some suggestions. Why don't you just train this model on the downstream task and use that trained one for predictions and inference. Thank you for that information, Hugging Face. Okay, so now we get to this thing training arguments and we pass in this. What do you think that we should call this step? So it looks like we're creating training arguments. What should we call that? That might just be kind of a read off. Ooh, this is interesting. So this is, got some good ideas here. Okay, so this number 8 is just kind of a declaration, sort of. So this one is just create training arguments. So this is just taking this training arguments class, which you can look at, which we will go into in a breakout room. But it's using one of the arguments here, which I think is the output directory, and it's constructing the training arguments. So then capturing default values. So let's see, did we run this one down? So there's a question about what training args is doing. So it looks like when we print the training args, oh my gosh, look at all of those values. That's really, really intense, right? So if we were actually to look at training arguments, so this is pretty intense right here. There are a lot of arguments to the training arguments. And you can see that some of these, so like do predict, have some default values. So this is what's populating some of those arguments that you did not explicitly write. So that is a really great question. Thank you for asking that. Okay, and we will look a little bit more into what we can, the types of arguments and the things that are available to us through training arguments. So this is just kind of like a statement, but we will see what this does more in a moment. Okay, so now we've created our arguments that we're going to use for training. And then let's see, we're doing this thing here. So maybe this one, nope, that one wrote it just as poorly. So now we're using this trainer. It sounds like it's training something. We're passing in the model that we loaded up before. We're passing in the arguments that we're going to use for the training. We're passing in the data set that we're going to use for training. So this is just a small one because it's a pretty big data set. We're also passing in the evaluation data set. Then it looks like we're calling trainer.train. Sounds like we're training this model using the arguments and training it on this training data set and an evaluating on an evaluation data set. Well, that argument is there. So what might we call this step? Ooh, yes, run model, train model. Okay, so let's call it that one, train model. And this one, we're gonna be a little bit specific about this. So without, oops, okay, we're gonna leave that part off, but we'll get to that in a second. So that's looking good. All right, let's see if this can run in a reasonable period of time. Otherwise, we're just going to kind of skip over that little piece. And then 10, this is an alternate that they kind of talked about, not an alternate, but like an augmentation. And it looks like, let's see, looks like we're loading a metric, an accuracy metric, and we're defining this function that will allow us to return a specific data type using the metric's default computation method. Interesting. So here, this is something that is kind of called under the covers. So it's kind of like you write this piece. And so like Hugging Face models call it. And when they call it, they want to pass in this specific thing. And so this specific thing is composed of logistic tables. You can get labels. You can get the predictions using argmax of these values and then use that in the computation here. So this is just a function that we define in order to return the computational metrics. Then what are we doing? It looks like we're calling trainer again. So now we're passing in the compute metrics. And this one is an evaluation. Interesting. So it kind of drew a line between what train is and what evaluate is. And I think this is just to show you the two functionalities. But what might we call this? Oh Lord, what might we call this? I like that. So this is kind of like involving two sort of things a little bit. But this is specifically evaluating the model. With compute metrics return. Okay. All right, so it looks like we have a good overview of that. And we're just gonna abort this thing here. But it looks like we have a pretty good understanding of what we're supposed to do if we want to fine tune a model, right? Because we literally just then outlined all the steps. We need to obviously have all the packages imported that we need. Then we're going to load up the data that we want to use in some sort of format. We're going to get the tokenizer that we want to use with the model. We're going to call the tokenizer on that data to get it in the correct format for the model. We're going to split that data into a train test split. So for our train validations or whatever split test that you want, we're going to split that data up. So we'll be able to train on some and test on the other ones. We're going to get the model that we want to use and get the weights at the end that we want to fine tune with, or we're just going to fine tune the model if it already has the task that we want. Then we're going to create some training arguments that are going to guide what the training is going to happen. And then we train the model and evaluate it. Sounds like we know what we're doing. So now I propose this. So now we say to ourselves, all right, I know what I'm doing. I already know the steps. We do know the steps. How, in our case, what differs from what we have just done? So if we had our own data, how would this differ from this particular set of code that we just looked at? There are also two really, okay, thank you, Jesse. So this here, this looks to be a function that we imported. Thank Pedro, perfect. So the problem here, okay, the struggle here is that we just loaded some data set. Like this is something that we got through Hugging Face, but we can't really do that because we don't have our data on Hugging Face. We have our data. Okay, so now what? Like we could like look really hard at this data structure and try to figure it out ourselves, which is, I mean, sometimes you do have to do that. But we can also go back here. Okay, so let's see if there's anything else that can help us here. Well, we might look at the classes. Maybe we want to look at, let's see, data. Maybe, nah, that doesn't sound exactly right. Are there any other guides? Oh, fine tuning with custom data sets. That sounds like it might be helpful. So what we looked at just then was just fine-tuning a pre-trained model. But there's another one in the advanced guides, which might help us now. So let's click on that one, fine-tuning with custom data sets. Okay, let's see. And this one actually does have a Collab link that goes to this actual code here. So now let's open this one together. And I'm going to leave this one open. If you start getting confused, like just tell me to close it and I'll just close it. But I'm keeping it open just so we can see if these steps sort of match. So let's see, let's open this one in Collab. We're going to open it with PyTorch. You could do mixed. That just means it has both the TensorFlow and the PyTorch implementation. But we're just going to focus on PyTorch for now. Okay, all right, so this is the exact code we had on the web. Let's see, so we can run this one again. You don't have to run all these cells. We can just kind of examine this because some of these steps might take some time. Oop, and it's saying that we haven't specified that. All right, and so we're just going to go through the rest of this and understand what's going on, and then we're going to take a break and come back and try it on our own data set. So now let's see what the difference might be. Fine-tuning with custom data sets. So let's come on back up here. So it looked like we already pip installed the things that we wanted to pip install. Okay, this is interesting. This is obtaining some data. And I think yesterday we talked about how we can use wget. Thank you for bringing that up, Jesse. Wget. We can also use tar to untar these things. So here, there's a server here which contains the data. And it's zipped. We can just use this exclamation point bash commands and just grab it. So let's do that. So that's going to take a second. Okay, so what is this? Because we didn't see anything like this in our other notebook now, did we? All right, so let's just take a second, wipe the sleep out of our eyes and take a look at this. Python people, if you were in the intensive, you are familiar with these things. You've seen them, so don't worry. Okay, so what are we doing? This one is doing something, so it's importing from the path. And so let's generally try to assess what's going on here. This is a function. Looks like we use the path. It kind of looks like, okay, so this is the directory. It looks like we're trying to get a list of texts and a list of labels. All right, it looks like they're separated, so the directory setup is organized into positive and negative directories. So, and those contain the examples. It looks like for everything that we read in, we're going to append the text to this text list and append the labels to the label list. And this will be given, to the labels list. And it's going to be one big thing that we're going to return. Interesting. Looks like we're trying to get the text and the labels. Interesting, out of our data. Interesting. So we wrote that function and then we call it on our data set, which has already been split. So that's kind of the setup of this one. Data set has already been split. We read in the data and we get the trained text. Interesting. And the trained labels. And we do that for both splits. Looks like the data structure they're using here is a list, and the data structure they're using here is a list for both of these. Interesting. So, all right, it looks like we have, let's see, looks like we've loaded the data. Okay, so we did all those things before. It looks like we're loading the data there. There's also something a little bit special about here in the sense that they've already done a little bit of split because that's how their data was set up. So keep that in mind. It looks like you can split maybe in different places. There can be different approaches. Okay, so we're kind of still on the same page. So this loading data looks a little bit different, but now we know kind of how we have to load it. All right, moving forward. So now they do a trained test split specifically on the training data. Often, if your data is large enough, you do like to have a train and a validation split. And so you can use that validation to tune your model. And then you can do a final test on the holdout set, which is the test data. So here is a trained test split. So we kind of talked about that here. It's a little bit out of order, but we know that we have to do it. There it is. So we do know we have to split the data at some point. All right. Okay, so we have lists list, and we use scikit-learn for this. Okay, so we split the data. That's just all that's saying. We split the data into training and validation. That's what that's saying. Then, oh, this is looking familiar. Subword tokenizer fast from pre-train. A tokenizer. Load tokenizer. Interesting. So we already completed loading the data, and also we did the split. And now we're loading the tokenizer. Let's see now. Okay, it looks like we're calling the tokenizer on each of these texts, and we're using our truncation and padding arguments to get our encodings. Okay, interesting. Interesting. So here we're doing this part. It's looking good. So we got our encodings. Let's see what else.
So Dr. Bell, I have a question about the tokenizers.
Yes.
So my experience with tokenizing, which maybe is outdated, is taking sort of a raw text, like a sentence or a paragraph or whatever. And what I always thought tokenizing was taking that paragraph and turning it into like a list or a vector of words. But I think what's going on here is you're turning them into integers, if I remember correctly from yesterday or the day before. Is that what's going on with these tokenizers?
Yes. So I
Okay.
actually love that question so passionately, because sometimes there are like a little bit of differences in like languages around this. So I've seen people refer to what Hugging Face calls a tokenizer as a combination of a tokenizer and like numericalization. So it's like it's two things. So the tokenizer might split it into words or subwords, and then from there you have another step, which is going to then convert it into the actual integers. So this one though is converting it into integers. And when we do our next exercise, we can take a look and see what these encodings are. And that might help to show a little bit more what this tokenizer is doing. That is
That'd be helpful, because I was trying to look at it on my own, and all I could find was like the text, and it wasn't clear to me what the output of the tokenizer was. I couldn't quite tell.
I love that question. We will take a look at that in our next exercise. If I do not bring that up explicitly, just stop me and force me to do it.
Okay.
And one final additional note about that too. Remember that it's doing subword tokenization. So sometimes entire words are tokenized if they're important enough. And remember, they're all at the very beginning, we talked about the different types of algorithms that you could use to determine whether you need to tokenize that entire word or whether subwords could be tokenized. Different algorithms, so things get tokenized in very, very different ways. But yes, to integers,
Okay.
which actually with some models is actually a way that some models cheat to run faster, is exploiting those integers.
That is such a great, I love that you brought that up. Okay, so let's see. Okay, so now we've got our encodings. Wait, where were we? Here we've got, okay, so we used our tokenizer. Here we're getting our encoding, so we got it thusly. So here, Lord, what is this? This is looking like madness. So this here, it looks like there's something simpler about this one. Because we use raw data sets, it already has this form that's consumable by Hugging Face. We have lists, we have encodings, we have labels. That's what we have. So now we need to get it into a structure that Hugging Face is going to understand. And this is what this piece is doing. So basically, just to quickly explain what's going on with this, talked about this during the Python intensive. This here is a base class that we're inheriting from. So there's other stuff going on in this, but we're inheriting from this, so we inherit that functionality. This is our class name that we're making. And with this, we're defining a few functions that Hugging Face needs to operate on the data set. Okay, so it needs, so first of all, this is an init method, meaning this is how you set it up. So you're going to pass in the encodings and the labels, and your class is going to keep track of that, or your object. Then you're going to define a get item. Get item is basically when you call something and you pass in an index, it identifies that thing and it returns it. So this one is going to be returning the item in addition to the label. Okay, so that is what the item is. And then you also need to define this function, which is length, which defines the length of your data set. So that's what this is doing. And this honestly, like it's pretty templatey. You'll see that maybe there was some copy and pasting in our next notebook. Okay, so this is just making this data set and defining these functions to be able to access the internals, so the items and the labels in a structured way that Hugging Face expects. Okay, so now that we've made this class, we populate it, right? So now we have this IMDb data set, and we pass in the training encodings and the label encodings as we said that we needed to, and we get back this object, which is of class IMDb data set, which Hugging Face wants. That's what the form they wanted in. So this right here is similar in a sense. This is a little bit of a different type of data set. So something that is just a little bit unfortunate in Hugging Face is that there's like the PyTorch data set, and then there's Hugging Face data sets, and they have just a little bit of a different structure and different like interaction. But the point is, at the end of the day, the thing that you're going to want to pass into your model and use is going to be something of a data set type, whether it's Hugging Face or whether it's going to be this PyTorch set. Okay, so now we have our data set that we want. We have our data sets. This also has data sets. This one is actually a data set dictionary, so it contains all of the all of the splits together, but that's neither here nor there. And then this one we actually have separated out. Okay, so we have a training data set of this type, validation data set of this type, and a test data set of this type. Okay, so this is another step of pre-processing that we just happen to need to do. So we still need to tokenize as we did before, but now here we also need to make it into the right form of a data set. So still very similar, pre-processing data, tokenizing, getting it into the class structure that we want. Okay, now let's see. So we already split the data above, as you can see here. Interesting. Let's open this one. Now we get right into fine-tuning the trainer. We've already done this. Oh wait, where do we do this? Okay, so this is actually here. So we can create a model for the task. That's what we're expecting to do next. That's actually this line, right? So they're creating a model, the Subword for sequence classification. So we still need to do that. We did the same thing here. We still need to create the training arguments. They did this here. Pedro, this also addresses a part of your question before. You can see that there are more training arguments specifically specified here to the interest of the creator. So if you need to specify any other things, you can look through the training or the API and specify those things, which we will get into a breakout group. So we training arguments, model for the task, then we do some training. Did we do that before? Oh my goodness, we did. Oh, look, it's still training. Okay, and so then we made, okay, so not exactly this though. No, exactly this. So then we did some training, okay? And so do keep in mind that you can always use these compute metrics during and with your training as well. And so this is just going to help you to get some outputs on what your model, how your model is performing. Okay, so now in our minds, we have some thoughts. We're one step closer to being America's Next Top Model. We're one step closer to being able to use our own data. Okay, so how is that? So when we loaded in the data, either we could do it with something like that, so we can untar and all that good stuff, or we can use the files that are in our own repository that we have now, or that are on our own Google Drive. Interesting. We might want to think about making them into lists of text and labels and split them somehow. And then we do all the things that we're going to do anyways. The difference being that we now just need to define this class, populate it, and then we can use this data set moving forward. So now we're going to try that. Not at this particular moment. We are going to come back in 5 minutes, and we are going to try this on our own data that we've mounted on Google Drive through the repo. Okay? All right, 5 minutes. I'll see you at 11:15. Let me go ahead. So now let's get started on using this notebook. Again, we're in the 5 notebook here. I'm going to go ahead and share my screen. Okay, actually, I'm not gonna. So now we've mounted everything. Red X if you need us to pause just one more second in order to finish up getting your drive mounted and all that good stuff. All right, looks like we're ready to go. All right, so moving right on forward. So here you can see that this line is actually commented out. It's because I'm just going to go ahead and assume that this has already been cloned in your repo or in your Google Drive. If it hasn't, just go ahead and uncomment that and then run the cell. Otherwise, we're just going to switch right into our drive and into the deep learning intensive folder. So let's pop right in there. And again, this notebook is using the custom data that we have in the repo about some different articles that have been written. And we're kind of switching our task a little bit. Here, we're just going to add some labels, and we're going to assume that maybe some of these writers are writers for Elle or People magazine, and we're going to try to classify the text given. We're going to try to classify the text and determine which magazine corresponds or which article corresponds to which magazine. So moving right along, as we know, and so these headers are numbered according to that notebook that we just did. So we can walk along and see how we can make this happen for our particular data. So now let's install transformers. It's also going to install data sets. Data sets is a Hugging Face package, but we're not going to use that. However, you could. And I think there's a commit a little bit further back in the repo, which uses data sets. Okay, we're making it right along. All right, so as we expected, we're going to be importing our packages. Something I didn't say before is that we can, so it is nice to have all of your imports kind of at the beginning. And so here we just add the imports that we're using. These are the same ones that we had pretty much before. So from data sets, we're loading this. Again, this is kind of if you wanted to use data sets. So the Hugging Face one, it's not the PyTorch one. But also from transformers, we're going to come back to pipeline, but we're using the auto tokenizer, auto model for sequence classification, training arguments, and trainer classes and modules. Lastly, we're importing Torch, and that is so we can inherit from that base class of Torch data sets. Also, blob, you know, the stuff. This is stuff we did before, and this is here just in case you want to use it in the future. Okay, so as expected, as we did last time, so this is just kind of an aggregation of the work that we did last time. We're reading in the files, reading in each of the files here. Again, I just would want to say that this is a way to approach this, but there are potentially other ways and better ways. And I think we saw potentially a better way in actually the last code we looked at through Hugging Face. So that is one reason I do kind of like reading through code, because it shows you alternate ways to do things. Anyways, so again, we're going to read all the file contents to a list. Sounding familiar? Then we're going to create our data frame so that we can merge it with our author data frame. And then we will have that at the end of this, and we'll just take a look at it. So let's run that one. All right, and this is what we kind of expect it to look like. Here, we're just going to do a little cheat. In your own data sets, you would most likely have the labels. We kind of just need to add some labels here. So we're going to make up some labels to add, and we're going to add them to the data frame, and it's going to be called a labels column. So here, again, this is just a way to do it. Maybe not the best, but it's a way. This is actually relatively important. This is the mapping between the value that you're going to, the integer value that you're going to assign to your class, as well as the name. So if you do label dict at 0, you'll get out L. Label dict at 1, you'll get out people. This is just a quick way to make some labels and mix them up. We are also going to do something kind of fun here. So we've seen 2 different ways to do train test split. We saw where we could use Hugging Face data sets. We saw where we can use scikit-learn. Sometimes it's nice for the split to be in the data frame. And so this works really great when you're collaborating across multiple people, and that when you want to kind of have the same splits for comparison. So you can create that right in the data frame and add it there. So this is something that you also would have wanted to save in that data frame. So here we just make a 15. So there's 20 in total. So 15 for training and 5 for tests. And we just make that column, tack it right onto the full data frame, and just look at it one more time to make sure things are making sense. So again, this is something, at least this part with this labels, this is not something you would normally have to do. Do make sure that your labels are integer values. If you ever see at the very end of your training where it's like, I don't know what the loss is, I don't know what that means in your dictionary that you passed in, that might indicate that you're using strings for your labels, at which case, how can you create, like, how can you calculate the mean square error on strings? All right, so make sure that those are integers. And again, this dictionary here is really great for understanding the correspondence between what is meant by 0, so the actual human readable class name, and the values. All right, so let's just take a look. So we've added some labels here. These are, you know, the 0 and 1 that we talked about there, and we added our split. All right, so as we did before, you know, we're going to take some steps, right? We know that we need to load the tokenizer. We know that we need to tokenize those inputs using our tokenizer, and we need to make it into a PyTorch data set, right? And then we know that we then need to find some sort of model. So these arguments are provided for you. We're just kind of skipping this one because we don't want to run train twice. And then we know that we're going to use, so for example, we're going to use the accuracy that they had. We're going to use the same compute metrics. We're going to use the compute metrics here and do a little bit of training. And then as you saw before, we're also going to do some evaluation. All right, so what is up to you? Well, we're about to pop into an 8-minute breakout room. So you guys can work together. Again, it's probably work best if someone shares their screen and everyone kind of decides what to write. And also you can use that previous notebook that we looked at, maybe even the one, like the first notebook, to create the tokenizers, and I guess that second notebook we looked at to actually create these encodings. So again, you'll be loading a tokenizer here. You can use the BERT base uncased, I think. BERT base cased, do that one. Or whichever one you actually prefer. Use the similar tokenizer, or use that tokenizer, then use that to create your encoding. Here, these are just some helper in case you need it. This is the class. So here we just have literally the same code we had before to create the class, because it's very, I mean, it's very templatey. Here we have just a different name just to customize to our application. This is articles data set. And here we need to convert our text into this articles data set form. Interesting. And we also need to do that for our validation data set. Interesting. Interesting. Lastly, we need to determine the model. Okay, so you can use the same BERT base case, but you're going to add some arguments here, specifically the number of classes, helper here. And you're also going to add this parameter ID to word. ID, class label, which corresponds to the human readable class name. What could that be? That kind of sounds like a dictionary that we just discussed. So you'll pass in those arguments. If you can't figure that out, you also don't have to pass in those arguments. But it has some results. You do need to pass in the number of classes though. Okay. So that's what you're going to be filling in. Basically, if it has a comment next to it, so this one and this one, you'll fill it in. This one and this one, you'll fill in. This one and this one, you'll fill in, and the tokenizer. So you'll go and work in your breakout rooms for about 8 minutes. Again, someone share your screen, and then we'll come back and see how this is working. All righty.
Your question.
So
Did you get to number, thumbs up? We got to number 5, through number 5.
I'm gonna be at 35.
Okay.
Right.
So did anyone get through maybe number 6 or 7? Anyone? Oh, a little bit? Okay. Did anyone get the whole way through? So to number 10. All right, so we're going to talk about this. We're going to talk about it. All right, so let me share my screen. So we are kind of a little limited on time, and I apologize. We were supposed to have like a little work session, so you'd be able to work on your projects, but it's kind of caught the whole time. Sorry about that. I think you're learning great things today that you'll be able to carry forward. So let's go ahead and see. So here, looks like we have the data, okay, labels, and split. Oh, and I think I was saying in interest of time, I'm just going to kind of go through these. So for the tokenizer, we are just going to load the tokenizer using the auto tokenizer. I think this was shown in the first example. So, so let's use the auto tokenizer. And we're going to get it from pre-trained. And we're going to use BERT base. Okay, and then if we want to know a little bit more about it, we can use this name. All right, so it looks like we downloaded and we got the name repack from it, just what we wanted. Good. All right, so now that we have the tokenizer, we want to tokenize our input text with this. However, for us, this also means we have to get the input text, right? And we want it from the training set. Okay, now that I'm looking at this, it's kind of a lot. Okay, so let's just look at this. So I'm going to uncomment both of these. All right, let's see. All right, so okay, we're going to start with getting the text of the training set. So we're going to use a particular thing we talked about during the Python intensive, where we're just going to use this query where the split is equal to 0. That's going to pull out all of the rows where the split is equal to 0. Then all we really want is this text column because we're trying to get the text. And then after we get those, all we need to do is convert that into a list. So that's going to give us our actual data, so our text in list form. And again, we just want to pass that into the tokenizer. All right. Thusly, we're also going to add some information about the truncation and padding. So truncation, we're going to set just to be true, and padding. Okay. So before you saw a padding of max length, this pads all of your inputs to the maximum length of that's allowed by the model. Now, what does this mean if all your text is like 5 tokens and the maximum allowed tokens are 512? That means you're just wasting a lot of space. It's going to take a long time to train and you're not really training anything. So another argument that you can use, and you can see this kind of in the documentation, is longest. So it looks and it's like, all right, which one of these is the longest text? All right, we're going to pad up to that. So that allows your data set and your encodings to be shorter. All right, we're just going to grab this one. I'm going to do the not good thing. So I'm going to copy this one and paste it. But we're going to make sure to change the split to 1. And that allows us to get the validation split. Okay, so with fold EF, use query to get the validation. So the rows where the split was 1, so the validation, we get the text column out of that, we convert it to a list. All right, so let's run that one. All right, that seemed to be pretty quick. So now let's examine what these encodings look like. Let's just type that in and look at it. Oh, interesting. So this output is kind of hard to kind of look at, but we have the IDs corresponding to the tokens. So this is input IDs. So you can see that here are the integers. And we also have, okay, so you might not be able to see it because I might scroll past it. Oh boy. Oh boy. Yeah, I think I've already made it past it. Whoops. Yeah, let's keep going. Yeah, I think that made it past it. Anyways, there are other fields in here, and you can take a look at those as well. Sorry, that's kind of what I'm looking at. There are also other fields. We may actually be able to see. No. Okay. All right. So these are some things that are available, but I think maybe they're not what we're looking for. Anyways, here or there. But I think this might actually just be the encodings. I might be thinking about data sets. But anyways, the point is that these are the IDs corresponding to the tokens produced by the tokenizer. And again, these may be subword tokenization tokens. So that's what that is. Then let's run this. We're just going to get the number of classes and the actual labels for the classes. I don't think we actually use trained classes, but that's okay. Then we create, okay, this articles data set thing. And now we need to create the actual training data set and the validation data set. So let's uncomment those. Well, we can use this class that we just made. And with the init, we need to pass in the encodings and the labels. So the encodings are relatively straightforward because we just made them. The labels, a little bit more questionable. So let's see how we can do that. So we're going to use article data set. What are we passing in? Again, we're passing in for train. What do we call that? Train encodings. Now we need to get the labels. This was actually in our data frame, right? So we're going to do something similar to what we did up here. But now what we want, instead of the text, we want the labels column. So we still want the rows where the split is 0. We just want the labels column. And then we're still going to convert it right onto a list. So let's see what that's going to look like. Well, full-tf.query. We're going to do split equals 0. We are going to get the labels column from that. Labels, hopefully. And then we're going to convert that to a list. So this is the training encodings that we passed in here. And then the labels we passed in here, which are integers. We'll again do the bad thing where we copy and paste. But we do know that for our validation data set, we need our split to be equal to 1. All right, and let's execute that one. Shift enter. Oh, didn't like that. Article data set. Oh, article data set isn't defined. Didn't I define that here? I sure did. I defined articles data set here. So let's fix that one. Oh, not there though. Come on, bud, work with me. Articles data set. See if that goes any better. All right, looks like things are going better. So because we have our train test split from above, we actually already have our train and validation data sets created. And keep in mind here, we just use a train and validation data set because our data is quite small. And so this might be sufficient for us here. So now we need to create the model for the task. Interesting. Well,
Hey, Dr. Bell, I think you got a mistake up there. You're on your val data set. You got train encodings as your first parameter for both.
Ooh, good catch.
that's why I don't copy and paste. Thank you so much. Val encodings. Oh, we're gonna make it. Ooh, I think we're frozen. Okay, val encodings. Thank you so much. That is a great catch. That was about to be a mess. Thank you very much. Perfect.
And sort of a nice note of warning, it ran just fine.
Careful when it runs fine. Careful. Thank you again for finding that. That was a great eye. All right, now let's create the model for the task. So we know that we're going to be using this one for base case. So let's just uncomment this one. Uncomment this one. These instructions are saying, look, you need to pass in a number of classes. We need to find that somewhere, and you need to pass in ID to Word. So this is not required, but you should experiment on what happens if you do not pass that in. The answer is it gives you default labels. So whenever you go to do your classification, it'll say label 0 instead of like L or people or positive or negative or what have you. So now let's see num classes. Oops. sorry, that's not num classes. Oh my gosh, I am so sorry. This is num labels. Whoops. Maybe that's why that was difficult there. Sorry about that. There's no parameter that's called num classes. Num labels. And we're going to pass in no classes. And so that is something that we made above just to count the number of classes. Length of the split, so the training split that labels. And then we're going to pass in ID to word, which is going to be the dictionary of the correspondence between the integer values and the human readable text. So ID to word is going to be equal to our label thick that we have. And we're just going to print that. So let's see how that goes. All right, we're downloading. Things are looking pretty good. Things are looking good. All right, it looks like our training arguments are set for O. Oh, it did not like that. I don't know why it, because I'm making up labels again. So this is something that you would need to find in config. It is not ID to word. It is ID to label. Just making up stuff, guys. Just making up Hugging Face parameters today. And so I just happen to be looking at the solutions right now, and that's why I can pick this out quickly. But if this were to happen to you, you can go and look at pre-trained config for text classification, and this is where these appear. So yesterday we talked about one of the pipelines, I think it was summarization maybe, where there were these two parameters that were passed in as keyword arguments that didn't really, like they weren't listed. And so those are the type of things that are passed to underlying model calls, function calls. So we get this, it's telling us again, A, what are those weights at the end? I don't know anything about that. So you should probably train this model on the task to be able to use it for predictions and inference. Thank you, Hugging Face. Okay, then moving forward, let's see, we have our training arguments prepared. This is going to be our output directory where it's going to store, I think, our checkpoints. And then we're actually just going to use this logging strategy called epoch, and it's just going to print some information for us about what's going on while the model trains. So let's run that one. Just made some training arguments for us. Great. Lastly, we'll just train the model using the evaluate, or not using, so this is very bad phrasing, but it's not good phrasing. It's not using the evaluation metric. It's more like printing or having it available for printing. So we ran this one. Basically, that just loaded our metric and we're using accuracy. Maybe not the best if we have an imbalanced data set. And then here you can see where we pass in our compute metrics, where it's just going to compute the metrics there. We have our train validation data set. We pass in the tokenizer, as well as training arguments in the model that we're using. We're creating a trainer and we're training it as we did before. Okay, so while this is running, so here is an argument that you didn't see in some of the examples. I encourage you to see what happens if you leave this out. And that will become clear in later stages when we can make it there today. Let's see, but in the meantime, we can do some we'll set these to run afterwards. This will do some evaluation. So before we had this kind of as empty, and what it does is it looks at the validation set, I believe, by default. We can also pass in a data set, so a PyTorch data set for evaluation and evaluate the results. So we can do that there. We can also do flat prediction. And so usually we tend to think about inference, but there's also this predict function that is provided that provides you like the values of the outputs in terms of the outputs of the model. So here we have this one, and we will make it, hopefully. Nope, we still have a couple more. Then this last piece is so exciting. Oh, sorry, go ahead. Oh, no, okay.
Sneezing.
The allergy season, I tell you. So then we have saving the model. Why do we care about this? Well, first of all, you can load it again in the pipeline and then use it on your actual text. So not something that you created into a data set, but the actual text. Ooh, fun. Also, this saves, if you had a tokenizer stated in your trainer, this will also save the tokenizer with it. Now, why is that important? We will get there in just a moment. So let's just run those. We're just giving things a second. So here's what the evaluate output looks like. It shows you about the outputs of what you were looking for. So this is going to be our metric. This is the loss. Things are doing a little well, aren't they? A little suspicious. But we can see that our training loss is going down. So I don't know, it seems to be training pretty well, but maybe that's a little bit too far. And let's see. Let's look at. So we looked at this one. Predict. You can see the actual outputs here. The API will describe a little bit more about what these are. And then here are your actual label IDs. So we had L versus people corresponding to 0 and 1. This is an output for each of our examples. And this tells us just a little bit more about our behavior with prediction. So these are measurements in case we want to make changes to the performance. So those are really helpful. Lastly, we have the save model. Okay, so let's run this one. So now we're saving the model somewhere. Let's look. We know that we are in our Google Drive directory. So drive. We know that we are in our deep learning intensive and we gave it this relative path. So let's see what's in there. Oh, this is the name of our model now, Intéressant. Let's just look and see what's in there. Oh, interesting. So it looks like these things kind of define the model. Interesting. The model and its configuration, and the tokenizer is in there with it, and the configuration. Oh, so all these look like great things that you would need if you were going to directly load it into a pipeline and do prediction or do inference with that. What if I did want to do that? Because really what I now have is the fine-tuned classifier using the BERT base, as it were. You can do that. So then we can come back and do exactly what we did yesterday. We have the text classification pipeline that we want to use because we just made this text classifier that we fine-tuned. And the model now is going to be our own file directory, right? This one, which is this one that we just created. Exciting. And then after we get that classifier back, we can just call it on the text or any new text. So this is just subtext that we have available through the data frame, but we could call it on other text. Interesting. Interesting. You can see it. You can see this down here. Call stack. All right, I'm going to that. Interesting. My goodness. Now we have the label outputs here that we fine-tuned on with the scores. Obviously, this model is not doing very well because it's not really confident about anything, but we just kind of made up these labels for the purpose of this example. So I don't, like, if it found any kind of correspondence, that's remarkable in itself. So now that we've done this, we have some really great insight on how we can use our own data to fine-tune a model. So if you need to do that, that is something that you can do. So that means now you're able to fine-tune models that already have the task, but you're also able to fine-tune models that don't have the task, and you can tailor it to your specific task. So that is very exciting. The last little bit is that not everyone here is doing text classification, and there are also some really great examples on how to do things like question answering, and I think maybe there are other examples provided. All right, let's see. I think, is that all? Yeah. Are there any questions? You have 4 minutes to get your whole project done. Now. Are there any questions? What questions do you have?
So I can take just the last few minutes to talk about what we're going to be doing tomorrow then. And also just emphasize what we just got finished with. So that model that we just pre-trained, if it was something that we thought was, if it were real on a real data set, that's absolutely a model that we could submit to Hugging Face. So one of the most valuable things that we have at Vanderbilt is a wide variety of data sets. And this is a way to turn those data sets into a valuable asset. There's a saying that in deep learning that your data is your source code. And that's really what's happening here. You're learning from your data and you're turning it into a model which can be used in a very broad and general way. So think about what can happen. You take your data, you do this training, and now you release it, and other people can do additional training on top of that, or they can use it as is, much like we've been using those pre-trained models as is. So Jesse, for example, if you find that there are particular types of financial statements that are more important, you grab them all, you train them on a particular task that you have that's important. Now you know, and you have all the steps to do that. Know that there are a couple of different ways that you can do the training. One is like this, where we could do it on your own. You could do it on Collab, you could do it on your local machine, or you can do it on our heavy-duty NVIDIA DGX A100. So you can do anything from small models to pretty large models. If you're uncertain about this, and we did gloss over a little bit over some of those hyperparameters having to do with the tuning, those can get more involved. We are very happy to consult with you on those, but also know that Hugging Face does offer a for-pay training, and they choose parameters really well. They have other algorithms behind the scenes that will choose those default settings for you, do the training, and then return that model just like we created that model. So that is yet another way to do that. So for tomorrow, what we'd like to do is a couple of different things. One, begin just by talking about a few practical items around deep learning, what to do about imbalanced data, talking a little bit more about the loss functions, about how you might augment data as well. I'll also be touching on the specialized models that don't have these nice pipelines already written around them, like the transformer, the vision transformers, the VIT models, VIT, vision transformers, and also the sound or the word to vec, I'm sorry, the wave to vec models. So whole different class of models that are available that you can also use. Then we'd like to take a time to do demos. And demos are going to be an opportunity for you or for a representative from your group, your research group, for those who are planning on doing projects, to share a little bit about what your thinking is at this point. If you've already actually done some training or things along those lines, great, show those, please do. But you can also just state what you think your plan is at this point now that you know enough about transformers. Are you going to be taking some model off the rack, be able to use that? Are you going to be doing some additional training? Do you think the training is going to be heavy duty? What does the plan look like for your project? We'll want to do that in the whole group because we also have students here who are interested in joining up in research projects. So this is an opportunity for you to do that. Then we'll break out into research rooms where we can just have different rooms, and you can invite people can opt to go in and talk to you a little bit more in depth about your particular project. And that's how we will finish up our deep learning intensive. Questions about today or questions about tomorrow?
Just a quick question on the training that we just did. You remember that diagram that you showed of all the different levels of the model that can be trained?
Yes.
Just to be clear, we were training the hidden layer. Is that what
we were going
all the way back? Okay.
All the way back. And so that is a great question. When I realize that we're past time now, so if you do need to take off, I understand. But thank you, because I've been wanting to sort of show this image again, just to put this in context. So let me show that right now. Just to be clear, you were doing the whole hog here. So you were doing everything all the way back. So we redid the encodings. We were training all of this, and that's why that gets to be heavy duty. But then you're getting advantage of everything. The other approaches that we talked about which are not covered here necessarily, but they just use those they just use the embeddings, and then you might do additional training. They call it gradients, but this could be regular machine learning as well. But the pipeline that you just saw was the whole deal.
Okay.
Yeah.
Great.
So, it was the whole deal, but you still were starting from a starting point, right? That's what the pre-trained model was.
Yeah.
So okay, all right.
Yes. So, and that's the nice thing. You can start with a pre-trained model. You can start with the base model, sort of the original BERT, the original Roberta, the original, whichever model you want to start with. Or you could start, in your case, for example, you could start with FinBERT and then go further. And that's the lovely thing about transfer learning, which really sets deep learning apart from machine learning and statistical learning. You have these saved models which save you time and are themselves sort of fungible. These are valuable assets that you can share and then other people can build upon.
Is the basic metaphor with this? It's like you're starting with these pre-trained weights. It's like putting you in a certain space in the optimization space that's kind of closer to what you would expect to be the final answer. Is that?
Yeah, that's not bad. Yes. Knowing that some of those weights are not yet defined, there's a lot more learning. One thing that we know now about these large language models is they can learn a lot more than we've taught them already. So there's much more room for learning. So you can think about these weights that are sort of free that can be used to learn other things or learn more subtle representations than currently exist.
Okay.
Excellent. Great questions. Other questions?
Just one last thing, and please feel free to ask questions after this. So earlier today, I was talking about going into a breakout room and using the API to kind of look through and understand some of the different capabilities of the classes. We obviously did not have time for that today. So please go to that breakout room document and look through the different questions that are there and try to answer them. It's really an exercise in trying to understand where you can find things in the API and what type of methods are available to you. So that will help you to understand that quite a bit.
So 2 things to work on tonight. One is to work through that. It's in the breakout room document. You can see all the questions listed there. Be a great thing to do, to go through and to solidify your knowledge from the things we talked about today. And second, think about what you might want to share in about 5 minutes or so. If you need a little bit more time, that's fine, but let's keep it 5, no more than 10 minutes to talk about research, about your project and what you sort of envision for it. If you want to show some graphics or some slides, you can, but really you can also just speak through it as well. Since we're all on the same page here about transformer models, you get to give this really high level talk, and all you really need to do is sort of talk about the thing that you want to solve and how you think you're going to be doing it. So put some thought into that so you can share with everyone tomorrow. All right. We'll stick around for a few more minutes if people have questions. Otherwise, thank you for hanging out for just a few extra minutes. Congratulations on training your first model all the way through. That is amazing. Amazing. Can't wait to see what you all do with the data. All right. See you all tomorrow.
So I'll stick around deeply. On that last, can you hear me?
Yes.
Because my connection is a bit rough. Okay. On that last question of, we're training the full thing and we were starting from some pre-trained models.
Yes.
Is there one of the hyperparameters essentially how much you want the model to be able to learn? In other words, how much will one example influence the full model?
Yes.
Is that okay? Okay, so that's one of the that you could fine tune, I guess. Or...
Exactly, and that kind of hyperparameter tuning is tough. And on the convolutional neural net side, we learned that those hyperparameters can be really important, especially things like learning rate and things like that, in order to get a better model. That's the one advantage to sort of submitting, stuff to Hugging Face. They sort of got that down. So it's a little bit more searching, sort of figure out, but this is how you would do it. And then on top of that, you might have to do some, start with good defaults. In deep learning, it's a little bit of more art than science right now, figuring out what those best parameters are.
Great.
And you can
I'll
look-
reach out because I'm really interested. Oh, sorry, go ahead. Go ahead.
No, go
I
ahead.
was just gonna say, you can look at the trainer class and the trainer arguments
Yeah.
class, and they have like, I mean, just this
Right.
huge array of different things that you can set in order to like kind of tune how much like each example sort of is going to influence the overall loss.
And Pedro, you're gonna say?
Okay.
And Pedro, you might be frozen now.